In this video, you will learn to solve a system of equations using the substitution method and the elimination method. In some books, the elimination method is also called as addition method. So here are the guidelines for the substitution method. So we choose one of the equations and solve it for one of the variables, and then substitute the expression found in step 1 into the other equation, and that will give you an equation in a single variable. And the step 3 is solve that equation, and step 4 is the substitute the solution which you found at step 3 back into your substitution equation and get the value of the other variable. And then make sure that you check your answers. So here is an example. You have to solve the system 2x plus 3y equals 5 and x plus 2y equals 4. So we'll select one of the equation to solve for one of the variable. Doesn't matter which equation, doesn't matter which variable. In this case, it probably is easier to solve the equation 2 for x. So that's what we are going to do. So from equation 2, x is equal to 4 minus 2y. And I'll call this equation 3. Then we'll substitute that in the other equation, which is equation 1. So we replace x by 4 minus 2y. And now we have an equation in y only, and we'll solve that equation for y. And we find that y is equal to 3. Now we take this value of y and substitute it back into the substitution equation. X equals 4 minus 2y, replace y by 3 to get x to be negative 2. So the solution is negative 2, 3. And make sure you check the solution whether it satisfies all the equations in the system or not. The elimination method is slightly different. If needed, multiply one or both of the equations by appropriate numbers so that the coefficients of one of the variables in one equation is the negative of the coefficient of the same variable in the other equation. And then add the two equations to eliminate that one variable, and then solve the resulting equation, and then substitute the value you found in step 3 into any one of the original equations, and that will give you the value of the other variable. And in the end, make sure you check your answers. So we're going to solve the same system using the elimination method now. And let's suppose we decide to eliminate x. If we want to eliminate x, the coefficient of x in the second equation should be negative 2, so that when we add the two equations, the x's get cancelled. So that's what we're going to do. We're going to multiply equation 2 by negative 2. So this second equation becomes negative 2x minus 4y equals negative 8. And then we add the two equations to get negative y equals negative 3, or y is equal to 3. And then we plug this value of y into any one of the equations. In this case, we selected the first equation, and that will give us x to be negative 2. So the solution, as before, is negative 2, 3. Okay, let's solve this system. 7x minus 5y equals 3. 4x minus 3y equals negative 7. In this case, it probably will be easier to use the elimination method, because if you use substitution, you will have some fractions involved. Okay, so we need to pick one of the variable to eliminate. And in this case, we decided to eliminate y. So if we want to eliminate y, the coefficients of y should be equal and opposite in sign in the two equations. So we'll multiply the first equation by 3 and the second equation by negative 5. If you multiply first equation by 3, you get 21x minus 15y equals 9. And multiply the second equation by negative 5, we get negative 20x plus 15y is equal to 35. And then we add, which will give us x equals 44. We plug this value of x in any one of the equations. Let's just use the first equation. Replace x by 44 and solve for y to get y to be 61. So the solution of this system is 44, 61, or x equals 44 and y equals 61.